So when you want to determine if a coordinate point is a solution to a system of linear equations, what you're really doing is you're trying to say if you graphed those two lines, is that the point of intersection of those two lines? Now, if it is, then what should be true is that if I substitute 3 for x and 1 for y in the first equation and simplify both sides, I get a true statement. And if I also substitute 3 for x and 1 for y in the second equation and simplify both sides, I also get a true statement. If I don't get a true statement in both of those, it's not a solution to the system. So what I do is I take my first equation and I substitute again 3 for x and 1 for y because inside the ordered pair, x comes before y. So 1 equals negative 3 times 3 plus 10. Now I don't know this to be true. I'm actually checking to see if it is. Order of operations says I should multiply before I add. So this becomes negative 9 plus 10, and then negative 9 plus 10 is 1. That is true, which means if I graph this line, y equals negative 3x plus 10, the point 31 is on that line. Now taking the second equation, substituting 1 for y and 3 for x, and then simplifying, I also get a true statement, so that point is also on that line. Which means, and paying attention to the format of the answer, your answer should be in the form, the ordered pair that I'm checking is or is not a solution to the system. Well, we just found that the point 31 is not just a solution, but is a solution to the system. It can be a solution to one of the equations, but not the other one. To be a solution to the system, it has to be a solution to both equations. So the second one, again, x is 4, y is 9. I'm going to take this equation and substitute 4 for my x and 9 for my y. The order of operations says I should multiply before I subtract. And then when I subtract, I get two things that are equal. So again, if I graph that line, the point 49 is on that line. Checking the second equation, again, substituting 4 for x and 9 for y, checking to see if this equation is true. Order of operations again says to do both multiplications before I subtract. And then when I subtract, I get the statement that's not true. It's false. Which means if I graph these two lines, and I'm not saying the two lines intersect or look anything like this necessarily, I graph these two lines, I found a point like here. It's on one of the lines, but it's not the solution. It's not the point of intersection I'm looking for. So the point 49 is not a solution to the system. Kind of hard to write on this thing sometimes. So that's learning target 4.1.